Sorry if the video fell off the page last video. For this box, please read page 576. Look at the 4 lines of equations in the middle. I already went over the gist of it with common logs, but make sure you watch the last video and read page 576, and then try 21 and 22 on your homework. All right, example 3. So they want us to find or solve 10 to the x equals 7 to the nearest thousandth. Please watch your decimal places with rounding because they are going to tell you specific numbers and place values, and you have to know to go that far. Exactness is a big deal. So 10 to the power of x equals 7. Well, we can't do the x through because we don't know what x is. But if I rewrite this as log base 10 of 7 equals x, again, I'm going with arrows, 10 of 7 equals x. Well, now this is all just numbers. That's a function. I can type that in. I can hit the log button. I already want base 10, so I just hit the log button of 7 equals, there we go, x equals 0.8 because it's nearest thousandth, tenth, hundredth, thousandth, equals x. All right, example 4. It does want to use the squiggly lines in the book. Okay, example 4, solve this. Log base 10, because there's no 10 you can see, x of x equals 2.873 to the nearest tenth. Well, now this isn't numbers, because I don't know x, but I can take my 10 to the 2.873rd power equals x. Well, now all this side is numbers, so I can type that in. 10 to the power of 2.873. So x equals 746 nearest tenth, 0.4. And yes, it should be squiggles. Okay. Example 5. Log base 4 of 8 equals what? So yes, you could type this into your calculator, but the point of logs is to realize that people didn't have your calculators at hand, and being able to go from large numbers to small numbers and make your life easier is the goal. So what they want us to try here is to rewrite this as exponents and then work backwards, okay? So I'm going to write 4 to the x equals 8. Now 4 and 8 have something in common. What do they have in common? Base 2. So this is actually 2 squared to the x power, and this is 2 cubed. Okay, if I take a power to a power, that's really multiplying. Well, now they're the same base. So they're the same base, and they're equal to each other. That means that these exponents are equal. So now I have 2x equals 3, and x equals 3/2. Okay? Yes, they're using small numbers, but the point is it's an example to build the habit and strategy, because you will see larger numbers, especially in 3 or 4 sections, where this strategy is the only way you can solve it because your number's going to be too big and your life will just be complicated. All right, and next one. We'll do these and then I'll pause for the graphing section. All right, write out how you would say each. I'm not going to write them, I'm going to say them, and I want you to write them as I say them, and then pause and try some on your own. I'm going to say them, not write them. This is 3 to the 4th power equals 81. You could also say base 3 to the 4th power is 81. Remember that in this case, the 3 is your base, 4 is your exponent. Equal signs mean is. Okay. On number 2, log base 10 of 10,000 is 4. You could also say the log base 10 of 10,000 is 4. So the equal sign is, the 10 is your base, and the argument is always of when you're saying it. And yes, you can just say log. You don't have to say logarithm. You can just say log. 3, base 2 cubed is 8. Okay? You could say to the 4th quartic power if you want the quartic, 3 quartic is 81. But after cubed, we pretty much don't say anything special. We just say to the fourth power. So 2 cubed, or 2 to the third power, I'll take both, is 8. Log base b of y is x. Y equals 10 to the xth power. Y equals log base 10 of x. You could also say both of these with is. Y is 10 to the x power. Y is log base 10 of x.